Okay, so I picked up this Rockwell grinder from Kijiji. It's 7-inch, appears to be from the 1960s. It's in fairly good shape for its age. Cast iron. Mostly. So we're just taking it apart here. It has a planer blade attachment on the left, and I thought about making up some parts to complete it, but later I decided against that. I might go back to it at a later time and finish it off, but for this rebuild I didn't get into that. Large aluminum eye guards on this thing. They just don't make them like that anymore. There's glass in there instead of plastic. It's laminated, kind of like a windshield of a car. Couple 3/8 24 threads per inch bolts does all the holding for the tool rests, and the way they made it there is you can get different angles and everything, so it's pretty well thought out. Just you can slide it in and out and put angles on it. 1/4-inch plate stamped. Those pieces were made out of. And the end caps here are stamped plate as well. They're not cast iron. Just using an impact here to speed things up, make it a little easier. There's the flange with a couple notches ground into it. I thought maybe somebody's trying to allow it to slide on the shaft easier. Wasn't sure, and the grinding job wasn't the greatest, or so I thought. Now this side's left-hand thread, so you just gotta pay attention to the angle of the threads on the shaft, and you'll see that it's different from a regular thread. Just gotta be careful there. Same thing again, there's slots ground in the flange. There's also a grease wiper here, felt. This is where I found out why there's slots ground in the flange. There's actually a roll pin going through the shaft. I've taken apart a few grinders and I have never seen that before. So there's why the slots were ground in the flange part there. For like a positive drive on the grinding wheel. I don't know why it's necessary, but that's the way they did it back then. There's some cracks on the flanges, and it doesn't sit on the shaft quite nicely, so Probably gonna make something up. So this motor can be wired 220 or 110. It's currently set up for 110. And I'm just actually writing down some of the color codes here and stuff, just so that I can put it back together, because I gotta cut a couple connectors. They're crimp connectors before I can continue with the disassembly. Cables are in really good shape. Like the wire exterior, I wasn't sure if it was changed at some point. So just taking the cap off, shorting out the terminals and measuring it on my cheat meter. It's 135. It says it's supposed to be 124, but that's within tolerance. So I'm not going to change that. So we got to pound these roll pins out before I can continue any disassembly. There's nothing coming apart without those being gone. Just cleaning up the shafts here with some stripping Scotch-Brite to clean off any rust or anything. And it still stops. So this is where I decide to whip up a puller here. I think they're 1/4 inch 16 bolts on here. So I end up just hand turning it off. It's all that was necessary, so didn't want to beat on anything. There's a shim underneath the bearing. And we do the other side as well. Taking care not to rip any wires off the start winding switch there. Just checking out the terminals. That bearing has a retainer screw on it. Here's the centrifugal start switch mechanism. A little sticky, there's some dried grease on there. I ended up taking that apart, cleaning it up. There's some aluminum spacers underneath this circuit board to position the board properly. So I'm taking the retainer screw out and just drifting out the bearing lightly. And there's a wave washer underneath this side, not just a flat shim. So that's gonna keep everything to one side, and that's probably why they have that retainer screw, so because the whole bearing's sliding in the bore. The bearings are Japanese, NTN I think. they seem to be in good condition, so I just decided to clean them up. They're a little dry, there's not much grease in there. So I'm just using a little Versol here. So I'm just blowing out any final dirt. And I'm angling the bearing here while I'm blowing it to keep the RPMs down. You don't really want to spin up the bearing fast. If it catches or locks up, then it's gonna probably damage your finger, and if it outer race explodes, then well, that's dangerous as well. So I packed the bearing up with grease here, and I think I overdid it, even though I wiped it out a lot of it, because it kind of came out between the dust seal at a later time when I started it. And I'm just going up the cleanup here. So putting this back together, the parts kind of interleave, so it took a little time to get it back together. I'm just putting the springs on, and we give it a little bit of light lubrication. There's some bearing washers behind those bearings. So I'm just cleaning up the contacts on the start winding switch here. They're in pretty good condition. I just wanted to clean them up just before I put everything together to make sure they're good to go for the next half a century. I use lacquer thinner a lot on this type of thing. It takes off any glue, oil, and it dries completely clean, so it's good for pre-painting. Just flattening the nameplate there, scuffing it up a little bit, and the wire wheel. This is what we did the majority of the job with, and it took quite some time to do all the parts and cover everything, but it worked out pretty well to remove the rust. You can see the hole there for like a push button start. This model has a blanking plate, and this toggle switch is actually in the grinder itself. The hole's still there for the push button start. She's using a little bit of anti-corrosion spray to keep any rust away. And this is the wave washer side, so I gotta put the retainer screw there so the bearing doesn't come out of its bore. Getting this back on is a little tricky because you got 3 screws, 3 spacers, and trying to line up everything, but just go delicate and everything's okay. So here's where I realized I forgot to put any type of alignment marks on the end caps, and it took me a good 10-15 minutes to figure out exactly where it had to go. Put it on, took it off, because I put them on 90 degrees out at one point. So if you're doing this, I recommend marking what you're, before you take it apart, the end cap position to the body. So I'm going to use a square here to align both end caps so that they're both sitting at the same angle, and I decided to use the bottom bolt in the shaft, and that'll put a slight upward tilt on the whole grinding wheel housing, so not overkill, but I think it'll just help me out with not being have to bend over as much. And it was an easy, quick way of lining everything up. So I ended up putting this masking tape on backwards so that I could slide it into the bearing past the housing, and then I just went the rest of the way with the masking tape, regular style. So I decided to brush paint it here. There's a couple of reasons. I didn't want to fire up the paint spray gun and, make some overspray, and also I think that actually brushing the paint in works the paint in a bit better for better adhesion. It's my opinion anyway. And it's a tool, so the finish doesn't have to be perfect. This is the blank off plate for the push button switch on the pedestal. So everything has 2 coats on the exterior surfaces and only 1 coat on some of the interior. It's not going to get much wear and tear. Another wipe down with lacquer thinner just to remove any oils from your hand or dust. Evaporates clean for the paint. And always pick off any loose bristles that fall off while you're painting. Just spray painted some of the silver things here. Well, I clear coated the switch plate and the motor plates just to keep down the wear and tear and preserve the graphics. This is like a clear coat for wheels on cars. So here's the eye guards. The light bulbs are a little weird. They're dual contact on the inside, kind of like an automotive bulb, but I think they're B22. So I ended up ordering some sewing machine bulbs for them from a Singer sewing machine. They fit the sockets. Laminated glass. The spring steel, I just cleaned it up and oiled it. I didn't paint those. Probably wouldn't stick from all the flexing anyway. So I just used a blade to scrape off the heavy material that was left on there. Little grinding pits and whatnot. And a light scuff with Scotch-Brite. You don't want to really go too heavy. That green Scotch-Brite is light to begin with, but you can scratch the glass. This has already been painted, so I'm going to just repaint it. I'm not going to buff out and do all that. So the paint is high heat paint for headers and motor parts. And it has a nice shine to it, aluminum shine to it when you're done. So we're making a high-tech blueprint here for the flange because I'm just deciding to make a whole new one. I thought I was going to be able to drill it out and put a new shaft part in, but the whole thing's made out of cast iron, so that's not happening. And that's probably why it cracked. And be a lot of turning down if they did make it out of steel, unless they cast steel or forged steel. So I'm just going to make it out of 2 parts because I don't really want to machine a 2.5-inch diameter piece of material down that much. It'll just take forever on my small lathe. So we're just using a little die chem here to make the scribe lines easier to see. This is for the tool rest. I'm not even going to measure it or anything. I'm just gonna kind of use the square and trace the part itself. And that'll be close enough. So the shoulders of this is a thicker material than what I'm going to use, but the 1/2-inch plate I'm going to use is more than strong enough for the threads that I'm going to cut in there. It's steel compared to the cast. So more die chem, more tracing here. So I'm just going to cut it out and using some cut-off wheels. Probably went through 3 wheels on this and just tried to figure out the smallest amount of cuts I could do to get it out of this plate. It's pretty heavy for this grinder, this 1/2-inch plate. trying to keep all the sparks and material going out the door instead of over the equipment as well. Grinder heated up pretty good on this job, so I kind of went slow. I didn't want to burn it out. I think this is the smallest grinder DeWalt makes, and it's really nice because it's lightweight and maneuverable. Just untwisting the cord there. So this belt sander comes in handy for metal work. Just taking the facets off the shoulder of the tool rest here, the shoulders. And it kind of evens them up a bit while making the rounded portion. So there's the parts there, cut out, ready to be worked on further. So I'm kind of cutting the wrong way here on the lathe. I'm not a machinist or anything, but that's the bit I had, so I'm trying to do a skim cut here because I don't really want it any smaller. It's already the right size. So I'm really undersizing it, but I think the felt wicks will take up the space anyway, so I'm not too concerned. It's only like 10 thou max, smaller. So I use drill bits to get out to close to the size I need it. Power fist, gotta break out power fist here. Silver and Deming bit, a little big for this taper on my tailstock, so I want it to turn a little on me. So I ended up tapping the part true. The zinc hammer comes in handy for that. And the bit, I kind of set it in the taper better. Get it done. Cheap and cheerful. So I used a boring bar the rest of the way. Can't really get a good shot on it. Just the way the lathe is up against the wall and there's no camera room. And also the tool holder's big, so I used a small boring bar to bring it out to the size for the shaft. So I'm tacking up the shoulders for the tool rest here just to keep them together for the drill and tap operation, just so nothing moves. A little tight there on the clamp, I couldn't get it undone. Just a shout out to Jody on weldingtipsandtricks.com. I learned everything about TIG welding from him. He's just an excellent reference on all things welding. So I highly recommend checking him out for if you need to know how to weld. Not saying I know anything, but I can get by with the information that I learned from him. So the shaft's set down from the face here so that when I turn it, there's still going to be some weld left to hold it. I also put it back in the lathe after I tacked it and hammered it as close to true as I could get it, just to keep the cutting material down to a minimum from the face. So I did all this in one clamp of the chuck. I didn't want to move the part between this facing operation and the boring of the internal hole for the grinder shaft as well, so just to make sure everything stayed as straight as I could get it. You don't really want to move it when you're doing something like that. This back angle, I was thinking about not doing it just because it would be more time and work, but ended up having to do it because it has to clear the housing of the grinder, so it makes it look nicer as well. I'm not a machinist or anything, so might not be using the right bit for everything, but it worked out in the end. So we're just scribing the whole positioning for the shoulders of the tool rest here. Center punch. And I'm just filing off any high spots from the grinding operations so that it sits flat in the vise. Because I need to drill this hole pretty straight. Don't want it going off on an angle. Sorry about my shoulder there. This is a tight area where I got the camera, so my hand gets in the way a couple times. So anytime I'm drilling a hole through a lot of material where I want to keep it straight, kind of let the drill bit center on the center punch hole. You don't want to see any deflection in any direction on the small drill, well, on any drill bit, but the small one particularly because it can flex. So you just ease into it and then clamp it down when you minimize the deflection. That way you got a decent chance of going through the part straight. The further you go, the more you got a chance of getting off on an angle. So here I'm just doing it the quick way. go up till the drill bit doesn't fit the hole and go down one. I don't have every drill size possible for the taps, so this will work out close enough. I did the same centering technique on this larger drill, although it's not as critical because the larger drill bit doesn't want to flex. So I'm just chucking up the tap in the drill chuck here. This way I can keep the tap straight, starting it off in the hole. It just keeps it perpendicular to the part. Just need a couple turns on it, so I'm just doing it by hand with a little downward force as well. And let off when you're coming back out. That way, when we get going tapping, it's just going to go through straight, no hassle. And it worked out well. The tap was really sharp, and it just smoothly went through it. Just using the belt iron to cut down any angles and clean it up a bit. So I gotta grind some relief in these parts for the weld bead. A little more surface area for the weld bead to go into, and also it'll be flush, pretty much flush to the surface when I'm done, so that's what I want. I won't even have to grind it off. Just using a flapper wheel here to finish off, take the mill scale off for welding, so it doesn't cause any welding contamination. Just using the drill bit to keep the holes lined up while I tack it up. So I'm just going to mark out the slot depth here. It's a little less than the one. Oh, okay. So there's the finished part. I'm going to have to grind an angle on the front of it there. Okay, back to my editing's kind of a little rough. Yeah, I thought I was going to do a really good job of grinding these slots compared to the factory, and that is easier said than done. So, just going to put the eye guards back together here. There's a spacer in the center, but none on the edges. Just relies on the aluminum and the closeness of the screw to it. So you can't over tighten that or it'll warp the whole tin plate. Using a little rubber tape here to make the cord fatter so it doesn't pull out, because it had that problem before. Alright, let's just look down in there. There's the new flanges. It's coming together. I'm just setting the original wheels back in. Well, actually, I'm going to use this gray one, but on the other side I end up getting a wire wheel because it's just something that I'm going to use more. And the white wheel was actually a narrower width. It works, but it just doesn't look as nice because it doesn't center up to the tool rest. I forgot to put the spark guards at the top as well with this assembly here. I got new bolts just because they were a little marked up, galled a bit on the heads. Tool rest bolts, that is. So there you have it. Hope you enjoyed the video, and there it is, assembled and complete. Bye.